Welcome back to College Algebra and to the final video in our series about linear and quadratic functions. This will be about solving quadratic inequalities. So it's almost a little bit of a digression. The stuff we were doing in the first four sections here when we're talking about the stuff we were doing earlier when we were talking about functions, this is talking about inequalities. So in a sense, it's a throwback to chapter 1 when we were talking about solving equations and inequalities. These inequalities are a little bit different though because they're not going to be linear. Right? Basically, all of the rules we studied for solving inequalities were dependent upon them being linear inequalities. It doesn't mean the rules no longer apply, they're just not as helpful. I mean, a linear inequality, you still move the 7 over and divide by 3. But if you got like a quadratic inequality, x squared plus, say, 4x plus 3, and that's less than 0, well, how do you solve this? If it were an equation, we'd say x plus 1, x plus 3 is less than 0, and then, which is still true, and then in an equation, we'd set up x plus 1 equals 0 and x plus 3 equals 0. Is this true? Well, the truth is it is not, and if you actually check your answers, you can tell, because you plug in -4, you would get -3 times -1, which would be positive 3, which would not be less than 0. So this wouldn't be true at all. So how do you actually find the solutions? Well, there's a general method for solving basically anything that's not linear. And it just really has 2 steps. You find boundary points. There's 2 real ways to do this, and we'll look at both of them eventually. Right now, we're just going to look at one of them. And use those to divide up the number line into intervals, and then test those intervals, either graphically with a graph, or numerically. Neither of them are particularly difficult. So let's look at some examples. Alright, so let's start off with problem 8 from the section. This is fairly typical as they go. We've got x squared minus 3x, or x squared plus 3x minus 10 is greater than 0. Note, this is actually a factorable polynomial, and we're actually gonna solve it the same way as before up to a point. Because if you think about it, we get x plus 5 and x minus 2. When we get -5 and positive 2, because that's what we would get, these are not solutions, but they are boundaries. Because think about it. It has to be greater than 0. Well, it is 0 at -5 and positive 2. That's what we were solving when we found these. Well, if these are the only places where it's 0, then what else can it be? Everywhere else. Either greater than 0 or less than 0. These are the only places where it can be 0. So that means our solution intervals are going to be around these things, but not at them. So that's why we use these to divide up the number line into intervals. So we've got -∞ to -5, -5 to 2, 2 to infinity. One or more of those will be our solutions. So how do we find it? Well, we do a simple test. If we plug in values in here, and in here, is it going to satisfy the inequality? And you can just do test values. That's what I mean when I say do it numerically. So we can just plug in -6. You plug in -6, you get -1 times -8, which is greater than 0. So this is part of the solution. You plug in 0, because that's in the middle here. You get 5 times -2, which is negative, so it's not greater than 0. You plug in 3, you get 8 times 1, which is greater than 0, so that one's in our solution. So our solution is negative infinity to negative 5 union 2 to infinity. Now, I honestly think there's an even simpler way of doing this, and that's using the graph. You don't have to make a very complicated graph, because we know what this looks like. This is a quadratic function on this side. What's a quadratic function's graph look like? Hopefully you said parabola. We just hammered that in for 2 videos. So, a parabola comes from a quadratic function, upward or downward facing. Well, remember our little memory device has a positive sign on A, so it is going up. So it's an upward facing parabola, and it goes through these 2 points, which is where it's 0, so those are its x-intercepts. If it's upward facing, that means it looks like this. So now tell me, where is it greater than 0? Where are the y values greater than 0? Well, on the edges. Sure, this is where it's above the x-axis. Over here and over here. With that in mind, all of these quadratic inequalities are really easy to test if you can just recognize whether it's an upward or downward facing parabola. Since it's an upward facing parabola, this one came out to be on the edges. If it were a downward facing parabola, it would be in between. For this problem, we'll have to do a little bit of solving work first, a little bit more than last time. Because to solve a quadratic equation, to find the boundary points, we have to get 0 on a side. So I multiply off the 2, 4x squared minus 6x, bring over the 9, greater than 0. Let's see, if we factor this, I don't know if it will factor, let's see. 4 times 9 is 36. I need a factoring pair of that adds to be negative 6. I don't think that's going to happen, because the closest they get together is 6 and 6. That gets you 12. Every other thing is going to have a higher addition when I add them together. So it doesn't factor, so we do quadratic formula. Let's see, negative of b's. Well, I'll write the quadratic formula just in case you don't know it by now. Again, it is one of the things you should memorize in this class, but I understand not everybody is necessarily going to be up on that. So that'll be 6 plus or minus the square root of b squared, so that's 36 minus 4 times 9. Over 2 times 4. I think that inside there, yeah, that inside there is going to be negative, so this is imaginary. So there are not going to be any boundaries on the number line. You might ask, well, how does that work? How could there not be any boundaries on the number line? Well, it just means there's no x-intercepts. So that means since it's upward facing and has no intercepts, it has to be up here somewhere. Because if it were down here and upward facing, it would cross the x-axis. It doesn't. So that means it is always greater than 0, so the answer is negative infinity to positive infinity. If it had been less than 0 instead of greater than 0, we would have said no solution, the empty set. But since it is always greater than 0, negative infinity to infinity. Let's do this one. Got 2x squared, bring everything over, minus 5x minus 3, less than 0. See if we can factor it. 2 times negative 3 is negative 6. Other factoring pair, the only other factoring pair of 6 is 1 and 6. Those do have a difference of 5 though, so negative 6 and plus 1. Let's see, 2x squared. I'll do the 6x first. Minus 6x plus x minus 3. Pull out a 2x. X minus 3. And that's already x minus 3, so 1 times x minus 3. Pull out the x minus 3. 2x plus 1 less than 0. So that means our bounds are at 3 and -1/2. So 3, -1/2. This is another upward facing parabola, so we want to know where it's less than 0 though, which would be in the middle. So that would be -1/2 to 3. I think that's where we'll end this section. Next time we'll come back and talk about polynomial functions in general for the first time as we move into our 5th chapter of what would be our textbook. Some interesting things to be done there. We'll also talk about rational functions soon after that, which are related, as are rational expressions to polynomials. Rational functions are basically related the same way. We'll also revisit nonlinear inequalities in Chapter 5. These were only quadratic ones, but what about higher polynomials or rational inequalities? We'll talk about those there. But generally, this is the process. Find boundaries, test them. So, see you in the next video. Have a great day.